Go!
Hello everyone, welcome to Practical GCP. Today I'd like to talk about BigQuery Federated Queries for Cloud SQL, which gives you the ability to access data directly from Cloud SQL in BigQuery, like a native table. So let's have a look at how it works and why it's very useful. So for many businesses, you would have Postgres or MySQL as your primary database that you use for your core systems. So these are typically the relational database of your backend transactional systems. Are super critical, lots of traffic, read and write combined, right? So the way this works is you typically have these databases here. In a traditional way, right, you can see that I've mentioned here that you typically have to get data through some form of ingestion, let's say querying some tables, find the deltas, and get this data into kind of analytical space, right? But in this case, because the way it works is you have this so-called external connection, right? Directly connected, or you can see it's mounted into like a BigQuery's engine directly from the backend. So what you have access is a real-time access to all your data, right, in those databases without any form of ingestion involved. This is very important because in a majority of the cases where you may need data in there is you want to see exactly what's in the latest state of those, right? And then maybe cross-reference with data you already have on BigQuery. But what you can even do better, and in a lot of these use cases, this is really useful, is not only you have access to real-time data, but you can also kind of redirect your data into a native table later on. So let's say if you have a DBT use case that runs every 5 minutes or 15 minutes for some new real-time use cases, you don't actually have to worry about the latency of this data in those Postgres or MySQL servers because your federated queries would hit the most latest version of the database directly, right? So that's how, in a nutshell, how it works. And this is why it's also very important, because you save all of this process of ingestions, because then, it depends on who does the ingestion, right? If you have a team does the ingestion, whatever latency you've got, it wouldn't be as real time as you can just query the database directly. There's a few things I want to mention here. One, obviously, is a read-only access. So this is kind of common sense, but also I want to mention here that the reason that this is all read-only, even by design, is you don't remotely want to have anyone tap into your core transactional database and try to write back into that, right? So that's just never a very good idea, even it does support it. So these are all read-only connections. And when you actually read the data into BigQuery, these would not be the same performance as a native BigQuery table, because that's why it's kind of called federated table, is because it's those federated queries, they actually run directly on those databases, right? So your query actually run as you issue them from BigQuery, which I'll show you in a bit. They will actually run on those databases. That's how you get the real timeness, but at the same time, you need to give thoughts on exactly what's going to happen on those databases, right? So because they actually run physically on those databases. So let's have a look at a example I put together on what it looks like when you're actually using it. So this is a database I put together, is MySQL, and I put it on the Cloud SQL engine that Google provided, right? So you can see that this one has been running for a while, and if you wonder why I actually have a private IP but also a public IP, so this is a restriction of the table federations. If you want to do the table federation, you need to have a public IP. But don't worry too much about it, because it's not ideal to have a public IP, but you do not have to give access to anything. So unless you deliberately assign this, give it access to some external resources or IP ranges, it would not be accessible by the outside world. But make sure you do check it, make sure it's not accessible via public, so no one can actually connect to it. And the only way you can actually connect to the database is either via the cloud IAP or from within your the cloud environment, or via the table federation through BigQuery, right? So I've got this database. I've chucked some data in there. If you look at I've got in data group, This is just a GUI tool that I've used to connect to the database. So behind the scenes, this uses the Cloud IAP. If you don't know what that means, you have to check out another video of mine. So it explains how you can use Cloud IAP to connect to such as Cloud SQL databases. So in here, I've chucked some dummy data in there. You can see you've got customers, employees, offices, whatever, right? So just quite a lot of dummy data, typical relational database structure of a normalized structure, right? So not just one table has everything, but lots of tables kind of linked together. So you can see that if I click on these things, this is the customer table data, this is the employee data, and so on, right? So this thing, right, now within BigQuery, what you can do is, the way you can do that is either via the gcloud command or other mechanisms, but this specifically in the UI, you can also see this is called external data source. They can add from data. So once you open it up, you've got these options that you can connect to the Cloud SQL environment. You can see what I've got is MySQL, the connection ID, and a bunch of other things you need to specify, right? But you can see I've already done one in there. So you've got a connection ID, which is shown already on the other side. You can see it's here, the connection name, right? You can use that. And then, but once you've got it connected, you kind of put in the database name. In my case, you can see it mapped into this classic models schema, and then a few other things, including the credentials that you set in there. So this is not like mounting a table or anything like some other table federation, right? This is just this is building a connection to this database. So you can actually do whatever you like on this database after it's connected. So let me show you an example. Now this connection is established. What I can do is, this is example query I've provided in there. So you can see the query I've actually done is selecting using the external query keyword, and then referencing the connection ID followed by the query itself. So in here you can see actually, as I mentioned earlier, this physically runs queries, right, on the actual relational database. In this case is MySQL on Cloud SQL. And when I run this query, it actually executes it on the database straight away and then pull the latency information. So in this case, I've actually done a join. So if I run this query, you can see that it has actually done the join between the order table and the customer table and produced the data for me in there, right? So the other thing I mentioned about earlier, which is very key, that why this becomes very useful, is you can actually redirect this just like a native table. So in your query settings, so obviously you can run this with dbt, with Airflow, with many other tools. You can basically say, I'm going to save it to a data set. In this case, I'm going to save it into the BigQuery examples, right, which is here. And then I'm going to call it orders with customer, right? So, and then all I have to do is to make sure I select the same region when it runs, and then that should still work like a native table. So look, now this is finished. I've got orders with customers. So this, as you can see, is no longer a federated queries or tables. So it's a native table. It has a size, has a region, and you can preview the data just like a normal BigQuery table. So this is very important in your downstream processes. And because this whole process is real time, you don't actually have any latency in the middle. You're actually querying the database directly, and that's why it's so key in this design that when you're running these queries, you can benefit from the exact point of the database at that point in your downstream near real time kind of modeling process. So, but let's also have a look at a few other things. So there's a number of best practices that when you use this thing that you want to follow or you want to keep in mind. One of these things is the use read replicas. So this is a kind of a no-brainer for anyone kind of come from a transactional database background. The master database at the back end of the one that you use for read and write isn't ideal for this kind of read queries. Or you always want to have read replicas, which you never actually write into it directly, but the write is done through replication, that you read into those replicas. You do not affect the performance of your master database, right? So that's really, really key. Make sure in Cloud SQL, this is super easy. You can just select one or multiple read replicas, and then you can use the read replicas to connect to your federated queries and then give access to people to do that. So it does not affect the master database that you serve for read and write traffic. As I mentioned, because the queries run on those databases directly, so it does matter, right? Those indexes. If you have an index when you join the tables, you always have to keep those things in mind. It's not like you doing these things on a BigQuery table, which index doesn't matter. You just have some cluster keys, but one way or the other, it doesn't really matter because it uses hash joins. It still kind of scans the whole table directly in most of the cases. But these are, because it's a federated queries, so the queries run on the relational databases. So you must make sure the index is correct, because otherwise a query could take forever. Also affect the performance of the read replicas, right? Even it's not on the master database. So also these, because you're still using a relational database, and it's a very unusual thing that you just go select start from a table that, let's say, has 5 million records, right? That's something you can do in BigQuery with some modeling process, but it's very unusual to do from the relational database, because one is going to take a large amount of time, and then to transfer the data from the relational database to your BigQuery, maybe this in-memory store, to run your BigQuery part of it. But it's very unusual that you want to do that kind of things. So I would say it's one, keep in mind that how much data you're pulling, but if you have to query millions of records, so you could use these federated tables or queries as part of your ingestion process if you prefer. So you can do a write append every like 5 minutes, like to your downstream tables, that you can actually do your heavy aggregations in there for the 5 million records or 10 million records in there, rather than try to do that on the relational database itself. But if latency matters to you, then always trying to find or query what you need, right, from the relational database, because you're not trying to just pull everything 5 billion and then do something with it, but you maybe most of the time want to say, I want what happened to these customers at those points, right? And then that would significantly reduce the amount of query run. So think still is as a relational database. Don't think it's just because the table is on BigQuery, then do it in the BigQuery way, which is processing really large amount of data, pulling it through first, and then do some modeling later. But do that first bit on the database itself, getting last 5 days of data or 2 days of data, and do some aggregations, get the data you need, pull it into your BigQuery data store, then cross-reference with other data. So that would be a lot more efficient. Otherwise, it could take very large amount of time, and it also cause the performance issues on the read replicas. So finally, the public IP. This is something I mentioned earlier. Is a restriction, is a limitation on the Cloud SQL. You must have a public IP, which is a bit annoying, but it's not a big issue if you disable public access. Just make sure you do not give anyone anyways to access it via that public IP. But it will still work with the federated queries. It just wouldn't allow anyone to try to connect to the port directly from any public IP in the world. Okay, hope that's useful, and that's the end of the session. Thank you very much, and see you next time.
Go out!